This first problem here is a quadratic equation, and all that means is that the largest exponent we have is a 2. We call those quadratic equations. And you can, I think it's easier if you rewrite it with the largest exponent first. Make sure you get all the signs the same. You don't have to, but I'm just rewriting the same thing and putting the largest term first, the one with the largest exponent. So what we're going to use to solve this quadratic equation, and you can use it for any of them, it's called the quadratic formula. And you plug in numbers into this formula and you'll get the solutions just by plugging in the numbers. Now, what are the A, B, and C? Those are the numbers that come in front of our terms here. A is the number in front of the x squared. B is the number in front of just the x. And C is the number that's off by itself without an x at all. And once you have those A, B, and C, make sure you copy the sign down with it. So minus 4x would be a minus 4 for B, and minus 20 gives you minus 20 for C. Plug those values here into the quadratic formula. So negative B means the opposite of what we have for B. And since we have a minus 4, negative B, the opposite of that will be a positive 4. And then plus or minus, and all that means is we're going to get two solutions. We're going to first time run the formula and do a plus. We'll get one solution. Then we'll run the formula again and do a subtraction, and we'll get the second solution. But rather than write everything down 2 times, we just write plus minus to save some time. So b squared negative 4 times negative 4 will be a positive 16 minus 4 times a times c. So that's 4 times 3 times negative 20. Right? 4 times a times c. So that is, let me pull out a calculator, make sure I don't mess that up. I'm typing it in here. I get 4 times 3 times negative 20, negative 240. So I'm subtracting negative 240. The easier way to write that is just plus 240. Minus a negative gives you a plus. And then 2 times a would be 2 times 3, so I'm going to get a 6 on bottom. So now what you want to do next is reduce inside the square root. So 4 plus or minus 16 plus 240 is 256 over 6. Now use your calculator for the square root of 256. Hopefully it comes out nice. If not, you're going to have to leave a square root in your problem, but this one does come out nice. Let me change color here. This one comes out to 4 plus or minus square root of 256 is 16 over 6. All right, so now like I mentioned earlier, we have two solutions. 4 plus 16 gives you 20 divided by 6, and you can reduce that down. Let's see, they both are divisible by 2, so you get 10 over 3. I don't know how your instructor likes you to write answers, 10 over 3, or 3 1/3, or if you want to use decimals, but that's how I would write the answer, 10 over 3. And then 4 minus 16 is going to give you negative 12 over 6. So that reduces down to negative 2. So those are your two solutions. 4 plus gives you this one. 4 minus gives you this one. And every quadratic equation like this has two solutions. So here's our two solutions. And if you plug either one of these in, the left side will equal 0. So the left and right side would be equal. That's how you can check that those are actually the solutions. For this next equation, we want to square both sides in order to get the solution. And if you square both sides, you have to square the entire side. And this would be difficult with the minus 4 and the 5. It makes it more complicated. What you want to do is try to get the square root part alone by itself and then square both sides. So to do that, add 4 to both sides. We're going to start with that. And you add 4 to both sides. Next, you want to divide both sides by 5. And after you've done that, the left side only has the square root. That's what you want, because now when you square both sides, if you square a square root, all you're going to be left is with the part inside of the square root. So squaring the square root, we're just going to have x minus 1 over here. And over here, 2 squared is going to give us 4. And now you can finalize solving this by adding 1 to both sides, x equals 5. A key part of this is you have to show that this is actually a solution. If you square both sides of the equation, sometimes you can get something that's an erroneous solution. So after you get this, you should show that this actually works. Write a 5 in here for x and show that it reduces down to be an equal equation where you get 6 equals 6 on both sides. So plug your answer back in and verify that it actually works. So for this one here, it looks complex, but what you really want to do is get rid of the fractions. And after you've done that, it'll look a lot easier. So if you multiply this fraction here by an x on top and an x on bottom, or there already is an x on bottom. So if you multiplied by an x on top, the x's would just disappear and cancel out, and you would just have a 6. Now you can't just multiply a single value in an equation by something. You have to multiply everything on both sides in order to keep the equation equal. So I want to multiply this by an x on top, but I'm going to have to also multiply this by an x on top and this by an x on top. Then I multiplied everything on both sides by x, and so it'll stay an equal equation, but I'll also get what I want, that those x's cancel out. So if you can think what else we would want to do, then is multiply everything by an x plus 5, because then the x plus 5 would cancel out on top and bottom here. So let's write out what we're doing. I'm multiplying everything by an x and also by an x plus 5. I'm going to do that first term by that. On my next term, I'm going to multiply by x and also an x plus 5. Multiply that second term by that. And then over on the other side, you have to do it as well. You're multiplying by an x and also an x plus 5. All right, so the reason we did that is because now we have no denominator here, and now we have no denominator here. What do we have? We have an x plus 5 times 6, and here we have an 8 times x, and over here we have, I'll go ahead and distribute, 3x times x is 3x squared, and 3x times 5 would be 15x. And so you can do one more distributing here, x times 5, x, and x times the 6, and the 5 times the 6. And so I'm going to come back right here and write that. So you'll have 6x plus 30 plus 8x, so a total of 14x equals 3x squared plus 15x. All right, so I'm not going to do this one all the way through, but I'm going to take it one step further. I'm going to get a 0 on this side on the left, and on the right, I'm going to have combine everything. So 3x squared. I have 15x. Over here, I had a total of 14x. So subtract away those 14x, and you would just have 1x over here. And you have a positive 30. Subtract away that, and you'd have a minus 30. So now you can see you have a quadratic equation. That's why I left this formula here up to start the problem. You're going to identify A, B, and C, plug them into this formula, and you'll be able to get the solutions. For this one, these signs mean absolute value. It's how far away from 0 the expression is. And it says it's equal to 7. And so one thing about absolute value, if you have a negative, I'm just doing an example here. How far away is 5 from 0? It's 5. How far away is negative 5 from 0? It's also 5 steps away from 0, just in the negative direction. So no matter what you have in here, negative or positive, the answer is always positive. We're measuring how far away from 0 the expression is. That's what absolute value is. It's like a measurement. You take a tape measure. How far away are you? You're going to get a positive answer whenever you measure something. So to solve it, to get rid of the absolute value bars and be able to solve with algebra, you have to say, well, that part inside could be a positive 7, or that part inside could have been a negative 7. Either absolute value would give you back a result of 7, so there's two choices here. So you have to solve, and I'll let you do this, but you have two equations to solve. You'll get two solutions, one when you solve this one, and the other option when you solve this one. And yeah, you can plug in your solutions back into here, and you should get a 7 and a positive 7 when you plug them back in. I'm not sure about number 2 in the position equation, so I'm not going to be able to help with that. For 3, 5 minus 9i squared, anytime you square something, it means multiply it by itself. So what you're doing is 5 minus 9i multiplied by 5 minus 9i. And so you want to multiply everything in the first parentheses here by everything in the second. You may have heard of the FOIL method. You're going to be taking each term and multiplying it by everything in the second. So 5 times 5, you get 25. 5 times minus 9i would be minus 45i. And then you do the same thing with the second term here. You do it by multiply it by everything. So minus 9i times 5 would again be minus 45i. And minus 9 times minus 9 would give you a positive 81. And I times I would be I squared. And so I'll let you reduce this. You can combine like terms. So minus 45 would give you minus 90i. I squared. This is a definition and it's leading into imaginary numbers. You can't take the square root of a negative number when you have traditional numbering systems, but we have complex numbers, sometimes called imaginary numbers, and they're defined that the square root of -1 is equal to what we call I. It's just the name we gave to the square root of -1. Just like when we say if you have, how many circles are there, we gave that the name 2. There's 2 circles. So we made up a symbol to represent having that many. We called it 2. Well, we made up a symbol to represent the square root of -1, and that symbol is I. And so what is I squared then? If you square both sides here, you would have that I squared equals -1. Squaring a square root is going to cancel out the square root. So I squared is -1. So as you reduce this plus 81 I squared, you need to change that 81 I squared to an 81 times -1 because I squared is -1. So this whole thing would become minus 81 instead of 81 I squared. And so then you can combine it with the 25 because those are just numbers. 25 and -81, combine those. And you want to write your number part first and the part with an I second. That's what the directions mean by standard form. So as you do 25 minus 81, that part comes first, and then your minus 90i would come second.